Hello guys, I am Shivam Tiwary, your physics mentor at Prep for IISER. I am from IIT Dharwad and today I am going to discuss your beautiful chapter Electromagnetism, the PYQ of it and help you to get to your dream college. So let's get started and solve the PYQs. So let's come to the first question or the first question. It is saying that an electron of mass me and charges E is projected in the speed v making an angle theta with this, and we have to comment on the following options. So let's see. Let first of all eliminate the options. D option is saying that it will, C option is saying that it will move along the trajectory A. No, of course it cannot move along trajectory A because QE force will be opposite to this, so it cannot move in the A direction. So C option is wrong. D option is saying that electron moving along trajectory B with a final velocity v cos theta parallel to the electrodes. No, it cannot move parallel to the electrodes as B because there is a force QE and electron it has negative charge. It will have a negative force on this, so it will bend towards C. It cannot move parallel through B. Now let's come to the A and B option. We have to find the time of flight. So time of flight by motion we know that time of flight equals to 2v sine theta upon g. G is the acceleration due to gravity. Here g is q into E upon m. So A option is not correct because there is nothing multiplied by 2. So let's come to the B option. B is saying that displacement. So displacement equals to speed into time. So 2v sine theta upon E into E upon m into v. So 2v sine theta into cos theta, because v is v cos theta. So sine 2 theta v upon q into m. So option B is your correct option. It was a very good question. You need a concept of motion also and charge also, moving charge also. Let's move to the second question and try to solve it. An electric dipole having point charge plus q and minus q are separated by a fixed distance d is kept under the influence of a uniform electric field E, such that the axis of the dipole making theta equals to 45 degrees. So if the electric dipole is allowed to rotate in the xy plane with its center being stationary, what is the magnitude of the net torque acting on the electric dipole? So we know that torque equals to Pe into sine theta. Torque equals to P into P cross E equals to P into sine theta. So torque equals to P is Q into D. So Q into D into electric field E into sine 45 1 upon root 2. So Q D E upon root 2 will be your correct option. So option B is your correct answer. Let's move to the next question and try to solve it. It's very interesting question. It's based on the flux. A point electric charge Q is placed at a corner of a cube. What is the electric flux passing through the shaded surface ABCD of a cube? So if a point charge is at the corner of the cube, its 1/8 part is inside the cube. आप देख सकते हो कि जब एक क्यूब होता है तो वहां पे जब चार्ज हम कॉर्नर पे रखते हैं, सो 1/8 पार्ट ही अंदर होता है, रेस्ट 7/8 पार्ट इज आउटसाइड द क्यूब. सो Q/8 तो हमारे पास पहले से ही था. अब ये देख सकते हैं जिस कॉर्नर पे अटैच्ड है वो चार्ज, उस कॉर्नर से अटैच्ड जो साइड्स है हमारे, वहां से फ्लक्स जीरो हो जाएगा बिकॉज इट विल बी पैरेलल टू देयर सरफेस. सो फ्लक्स थ्रू ऑल द 3 surfaces will be zero. Rest 3 will be equal because they are equidistant from that point charge. So Q upon 8, and then again rest 3 will have equal flux. So तीनों के पास equal जाएगा. So divided by 3 also. So Q upon 24 epsilon naught will be your flux, electric flux. So electric flux equals to Q upon 24 epsilon naught will be your correct answer. And D option is your correct answer. So ये कॉन्सेप्चुअल क्वेश्चन था, ये बहुत ही इंपॉर्टेंट क्वेश्चन था, ये आते रहते हैं क्वेश्चन ये इलेक्ट्रिक फ्लक्स पे. सो लेट्स सॉल्व द नेक्स्ट क्वेश्चन एंड इट्स क्वाइट अ गुड क्वेश्चन. So it charge distribution inside a sphere of radius r equals to 2a upon b is given by volume charge density volume charge density rho is given as AR square minus BR cube. At what distance the center from the center the electric field goes to 0. So electric field DE equals to K dq by R square dr, K dq by R square, dq by R square. So dq we have to find, dq equals to 4 pi R square dr will be the small volume at that sphere into rho. So dE equals to K into 4 pi R square dr into rho upon R square. R square get cancelled. Integrate both sides. dE equals to K into 4 pi. Integrate rho dr. Rho is AR square minus BR cube equals to electric field equals to K into 4 pi equals to AR cube upon 3 minus BR4 upon 4. Now, electric field is asking to be 0, so make it 0. So AR cube upon 3 equals to BR to the power 4 upon 4. R cube got cancelled. So R equals to 4A upon 3B, where electric field will be 0. So 4A upon 3B option is correct answer. It's a good question because you have to find the thin spherical cell at a distance r from the sphere. Now the electric field of an next question, let's move to the next question. Electric field of an electromagnetic wave is given by electric field equals to E naught z cap cos of ax plus bt. If c is the speed of light, then value of b is. So it's completely based on formula. We know that k equals to omega into c. So b equals to a into c. We have to find the value of b equals to ac. C is the speed of light, so a will be your correct answer. It was very easy question based on the complete formula because we know that k equals to omega c. Let's move to the next question. 4 point charges q minus 2q minus 3q and 4q are placed at the 4 vertices of a regular tetrahedron. Okay, so regular tetrahedron is of this shape. And the most important part of this question is the center, the distance of center from its vertices of a tetrahedron is L upon root 6. This is the most important thing of this question. So distance of center of tetrahedron from the vertices is equals to L upon root 6. Now what we have to find? We have to find the individual energy density from all charges. So let's find for 5q. So energy will be k into minus 2q into 5q upon L plus k into q into minus 5q upon L plus k into minus 3q into 5q upon L plus k into 4q into 5q upon L. All, if you all find, means you have to find all the energy from all the charges, then you will come, because it's means only calculation is there, then we'll get to know that answer will come to a option minus 15q square upon 4 pi epsilon naught L. It's calculative question only, you have to calculate, because the most important thing that the distance of center from its vertices was L by root 6. Then you can solve anything. Let's move to the next question. Two spherical conductors A and B of radii A and 2A contain minus q and 2q charges respectively. They come in contact with each other due to electrostatic attraction and eventually move apart. What will be the ratio of final charge? Okay, so we have to find, this question is based on the potential of a sphere. So assume when they come in contact, when these two spheres come in contact, as these are conductors, their potential will be equal. And due to charge conservation, let's say that on smaller sphere there is a q charge, Then in the bigger sphere, it will be Q minus Q charge by charge conservation. Now equate the potential. So KQ upon A equals to K into Q minus Q upon B, that is 2A. We have to find Q. So KK got cancelled. So 2Q equals to Q minus Q. So small q equals to Q upon 3. And the charge on next another sphere is Q minus Q by 3. That is 2Q by 3. And we have to find the ratio of these charges. So 2 will be your answer. Ratio of the charges 1 upon 2. So sorry, Q by 3 upon Q upon 3 upon 2Q upon 3. So it will be 1 by 2. It will be the ratio of charges on the spherical cell. So B is your correct answer. Let's move to the next question. It's easy question. Two uniformly charged concentric thin spherical cell of radius R1 and R2 are maintained at electrostatic potential V1 and V2. So we know that in the conductor, there in electric field, potential in the conductor potential is uniform, so it will not change, so it will be constant. So B option and C option got eliminated, and by second derivative, uniform, first of all, uniform potential in a conductor, and if you do the second derivative, it will come if double dash is greater than 0, then upward facing curve will come. So A option will be your correct answer. Now next, let's move to the next question. A point charge Q is placed at a center of a conducting grounded cube. What is the electric potential at distance x greater than root 3 by 2a? So it will come simply, it will behave like a point charge because the charge is outside the cubical sphere, so cube will behave like point charge. So it will be KQ upon X only. So KQ upon X only. So KQ upon X. C option will be correct answer. KQ upon X only. It will because it will behave like a point charge. So it's a KQ upon X. Let's move to the next question. Consider 2 point charges plus Q and plus 2Q fixed on XY plane at minus L by 2 and plus L by 2 respectively. Another point charge minus Q having mass M is released from rest at 0, root 3 by L. So this is plus Q, this is plus 2Q, and this is minus Q. So we have to find the force on minus Q due to this plus Q and plus 2Q. Okay. So F1 equals to KQ square upon L square minus 1 upon 2I minus root 3 by 2 J cap. It will attract, because as the charges are opposite sign, it will attract to each other, and it will come F1 will be this by vector. You can find it's easy question. So F2 equals to KQ square upon L square into minus 1 by 2 x, wait a second, 1 upon 2 I cap minus root 3 upon 2 J cap. So X component got cancelled, so it will be F net equals to F1 plus F2 equals to KQ square upon L square 3 root 3 by 2. 3 root 3 by 2 will be your 3 root 3 by 2 I cap plus I cap minus 3 root 3 J cap, and here will be 2. So 1 upon 8 pi epsilon naught into I minus 3 root 3 A will be your correct answer. It was an easy question. We have to find the force of by vector addition. So capacity and capacitor mixed questions. So चलिए शुरू करते हैं. So the first question is, capacitance C0 consists of two spherical cell conductors. If the radii of inner and outer spherical conductors are halved, what is the new capacitance? तो हमें पता है that if two concentric spherical cells हैं, तो उनका combined capacitance जो आता है 4 pi epsilon naught R1 R2 upon R2 minus R1. and this is R1, this is R2. So in question it is saying that the radius of both the cells are half. So radius को half कर देते हैं, तो देखते हैं कैपेसिटेंस क्या आता है. 4 pi R1/2 R2/2 upon R2/2 minus R1/2. So capacitance equals to 4 pi R1 R2 upon 2 times R2 minus R1. So देख सकते हैं कि कैपेसिटेंस गॉट हाफ, सो कैपेसिटेंस विल बी C0/2. नीचे 2 आ गया, सो कैपेसिटेंस हाफ हो गया. So let's come to the next question. What is the time t taken by the capacitor in the given circuit to charge to 1 upon root 2 pi of its full capacity? So solve करते हैं ये second question. जानते हैं that we know that charge in a capacitor is of the form q equals to q naught into e raised to 1 minus e raised to the power tau, e raised to the power tau. Tau is minus t upon rc, minus t by tau, so tau is rc, and it is saying that q upon q naught equals to 1 upon root 2 pi. 1 upon root 2 pi in the question equals to 1 minus e raised to the power minus t upon rc. Take log both sides, so ln of 1 minus 1 upon root 2 pi equals to minus t by rc. What it's saying that it is saying टाइम कब होगा जबकि ये इंफिनिटी पे चल जाए. सो क्लोजेस्ट टू द आरसी टाइम इज इक्वल्स टू आरसी ln of 1 minus 1 by root 2 pi. So this option is closest to the rc, so our option D will be correct. P equals to rc. चलिए नेक्स्ट क्वेश्चन पे चलते हैं. The capacitor of a capacitance C consists of two large parallel metal plates. The coefficient of linear expansion of metal is alpha. What is the change in capacitance's temperature of the plates rises by delta T while the gap between the plates is kept. So ये aerial expansion पे question है. We know that for a linear expansion alpha delta T is required, and for a aerial beta delta T is the expansion, and also beta equals to 2 alpha. We know that. So let's solve this question. C equals to epsilon naught A by D, and this will be the aerial expression. D is fixed because the length between the plates are not changed, only the width of plates are changed. So C will be epsilon naught into 2 alpha delta T by D equals to 2 alpha into C will be the 2 alpha delta T into C will be the answer. So A is your answer. So चलिए next question पे चलते हैं. Next question is, what are the charges stored in the 2 microfarad and 4 microfarad capacitors in the given circuit after a long time the key is closed? So let's solve this question. जानते हैं that हम जानते हैं कि स्टेडी स्टेट पे कैपेसिटर्स वाले चैनल में करंट जीरो हो जाता है, बिकॉज वो इनफाइनाइट टाइम के बाद कैपेसिटेंस वाले वायर में और उसके सर्किट में करंट विल बी जीरो. सो करंट थ्रू दिस विल बी जीरो. दैट उस चैनल में जिसमें कैपेसिटर लगा हुआ है वहां पे करंट जीरो होगा. सो बाय ओम्स लॉ करंट फाइंड कर लेते हैं जो कि इधर मूव करेगा. सो करंट विल बी 12 वोल्ट अपॉन 4 4 2 6 2 8 4 10 10 के इक्वल्स टू 6 upon 5 milliampere will be the current. 12 upon 4 to 6 6 2 8 8 4 12 12 equals to means 1 milliampere will be the current. 1 milliampere is the current. So let's find the potential difference across these two capacitor across this network. So potential difference will be 0 minus 2 into 2 plus 12 minus 4 equals to V. मान लेते हैं कि यहाँ पे 0 एज्यूम कर लिया कि यहाँ पे 0 है तो यहाँ पे V है, तो V will be equal to 12 minus 4 6 वोल्ट. 6 वोल्ट आ गया. So we know that in capacitance Q equals to CV. So Q equals to C will be capacitance series में connected है, so equivalent capacitor will be 4 into 2 upon 4 plus 2 into V will be 6, 4 to the 8 upon 6 into 6 8. So capacitor series में है तो both capacitor will have the same charge, so 8 microcoulomb will be the charge on each capacitor. A option is correct. तो चलिए नेक्स्ट क्वेश्चन पे चलते हैं. In the given circuit, each of the resistor of 1 kilo ohm resistor and each of the capacitor is 4 microfarad capacitor. What is the charge in the capacitor between the points B and F? So let's find the potential difference between B and F. So V across BF will be by symmetry. It is a symmetrical question. By symmetry, VBF will be 3.75 volt. P2Q potential difference equals to 5 volt. So Q equals to CV. Q equals to C is how much? C is 4 I think given, right? 4 microfarads. C into V 3.75 equals to 15 microcoulomb will be your answer. So A option is correct. So it was an easy question. In steady state, charge stored in the capacitor C equals to 2 microfarad in circuit below. Okay, charge stored in the capacitor C equals to 2 microfarad. So again, the current through the network of capacitor will be 0. So current will be 12 minus 4. Potential they are in opposite direction. So 12 minus 4 upon 8, 8, 3, 11 and 5, 16. 12 minus 4 upon 16 will be the current. Equals to 8 upon 16 equals to 1 by 2 ampere. So let's find the potential difference across capacitor to know the charge, and Q equals to CV. We know capacitance is given. We will find the potential difference and multiply it. We will get the charge. So मान लेते हैं कि यहाँ पे 0 है पोटेंशियल, तो 0 plus 2 plus 8 plus 4 minus 12 will be the V here. यहाँ पे V मान लिया. So V will be minus 6. V equals to minus 6 volt. So the potential difference across the capacitor is 6 volt. So Q equals to C into V. C is 2 microfarad into 6. Q equals to 12. 12 will be the answer. चलिए नेक्स्ट क्वेश्चन पे चलते हैं. द करंट थ्रू द 36 ओम रेजिस्टर इन द सर्किट इज. सो ये इजी क्वेश्चन है. तो चलिए इसको फाइंड करते हैं. 1 अपॉन, सबसे पहले इसका इक्विवेलेंट रेजिस्टेंस फाइंड करते हैं. 1 अपॉन R इक्वल्स टू 1 अपॉन 4 प्लस 1 अपॉन 12 प्लस 1 अपॉन 3. ये आपका हो जाएगा 12 4 3 प्लस 1 प्लस 4. 12 4 3 is 12, 1 3 4 4 3 7 1 8 upon 12. So R equivalent will be 12 upon 8, that is 3 by 2, and in series with it 36 ohm is connected. So R complete equivalent will be 3 upon 2 plus 36, 75 by 2. So current will be 25 minus 10 upon 75 upon 2. So 2 upon 75 into 15. 5, 2 by 5. 2 by 5 is the correct answer. Current through 36 ohm will be 2 upon 5 amps. So ये भी एक मतलब करंट बेस्ड क्वेश्चंस था जिसपे V इक्वल्स टू IR कंप्लीटली निकालना था और R इक्विवेलेंट निकालना था, जो कि पैरेलल में भी थे और वो सीरीज में था 36 ओम से कनेक्टेड. सो नेक्स्ट क्वेश्चन इज, so this is it in this chapter. So thank you, and be connected with our team, and support us so that we can help you to get you to your dream college. Thank you.